Now coming to the second exercise, first question. A solid is in the shape of cone standing on the hemisphere with both of their radii being equal to 1 centimeters and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So here the radius for both hemisphere and the cone is given as 1 centimeter, and he is also given that height of the cone is equal to radius h, that is equal to 1 centimeter. Now he is asking us to find the volume of solid. So here volume of solid is equal to volume of cone plus volume of hemisphere, which is equal to volume of cone is here pi by 3 r square h plus volume of hemisphere is 2 pi by 3 r cube, which is equal to, let us substitute the values, pi by 3 into radius is 1 square into h 1 plus 2 pi by 3 into r cube, that is 1 cube, which is equal to pi by 3 plus 2 pi by 3, which is equal to pi centimeter cube. That is a solution. Now let us discuss question number 2. Rachel, an engineering student, was asked to make a model shaped like a cylinder with the two cones attached at its two ends by using a thin aluminium sheet. The diameter of the model is 3 centimeters and its length is 12 centimeters. If each of cone has a height of 2 centimeters, find the volume of air contained in the model made by Rachel made. Assume that outer and inner dimensions of the model are nearly same. Now coming to the solution. Here in the question he has given that Rachel has made a model with the cylinder attached with two cones at each ends, and the radius of cylinder or the cone is given by half the diameter of cone, that is half times diameter is 3 centimeters given, which is half times 3 is 1.5 centimeters. Now the total height or the total length of the structure made by him is given by, height of total structure is given by 12 centimeters and the height of each cone is equal to 2 centimeters. Now the height of cylinder will be total height minus 2 times the heights of cone, that is 2 times 2, which is equal to 8 centimeters. Let this be as capital H and let this be as small h. Now the volume of air contained in the structure made is equal to volume of cylinder plus 2 times volume of cone, that is equal to volume of cylinder is pi r square h plus 2 times volume of cone is pi by 3 r square h. Let us take here common as pi r square into capital H plus 2 by 3 small h, that is equal to pi r square is pi into 1.5 whole square into capital H is here 8 centimeters plus 2/3 times small h is 2 centimeters, which is equal to pi times 1.5 times 1.5 into 8 plus 4 by 3, that is 28 by 3. Here 1.5 goes in 3 2 times, which is equal to pi value is 22 by 7 into 1.5 times 28 by 2. Here 2 goes in 22 11 times and 7 goes 4 times. Therefore we left with 44 times 1.5, that is 44 times 3 by 2, which is equal to 66 centimeter cube, which is the solution. Now moving on to third question. A gulab jamun contains sugar syrup up to about 30% of its volumes. Find approximately how much syrup would be found in the 45 gulab jamuns, each shaped like a cylinder, with the two hemispherical ends, with the length of 5 centimeters and the diameter of 2.8 centimeters. Now coming to the solution. Here, he has given a container with the gulab jamuns in it and the 30% of syrup in it. And he has given that gulab jamun is in the shape of cylinder attached with two hemispheres at its ends. For the gulab jamun, he has given the data that diameter of the hemispherical ends D is equal to 2.8 centimeters. Now we get radius is equal to diameter by 2, which is equal to 2.8 by 2, that is 1.4 centimeters. And now let us find the height of cylindrical shape, which is equal to 5 minus 2 times this 2 radius has to be eliminated, 1.4, that is equal to 5 minus 2.14 is 5 minus 2.8, that is 2.2 centimeters. Let this be as some height h. Now we get the volume of gulab jamun each is equal to volume of cylindrical portion plus 2 times the volume of hemispherical portions, that is equal to volume of cylinder is pi r square h plus volume of hemisphere is 2 times 2 by 3 pi r cube, that is equal to, let us take here common as pi r square, then we get h plus 4 by 3 r, which is equal to pi value is 22 by 7 into r square is here 1.4 into 1.4 whole of h value is 2.2 plus 4 by 3 r, that is 1.4, which is equal to, here 7 goes in 1.4 0.2 times, that is 22 times 0.2 times 1.4 times 2.2 plus 4 by 3 into 1 by 4, that is 4 times 1.4 is 5.6 plus here if we multiply 3 with this, then we get 6.6 plus 5.6, that is 12.2 by 3, which is equal to 22 times 0.2 is 4.4 times 1.4 times 12.2 by 3 centimeter cube. Now the volume of 45 gulab jamuns is equal to 45 times volume of 45 gulab jamuns is equal to 45 times volume of each of one, that is 4.4 times 1.4 times 12.2 by 3, which is equal to, here 3 goes in 45 9 times, and we get the value of 9 times 4.4 times 1.4 times 12.2 is 1127.28 centimeter cube. But we need the volume of syrup. He said that volume of syrup is equal to 30% of the volume occupied by the gulab jamuns, that is 30% of 1127.28, that is 30% of 1127.28, which is equal to 30 by 100 into 1127.28, which is equal to, the approximate value is 338 centimeter cube. That's the solution. Now coming to the fourth question. A pen stand made of wood is in the shape of cuboid with the 4 conical depressions to hold pens. The dimensions of the cuboid are 15 by 10 by 3.5 centimeters. The radius of each of the depressions is 0.5 centimeters and the depth is 1.4 centimeters. Find the volume of wood in the entire stand. Now coming to the solution. Here he has given the cuboid with certain dimensions. Here he has given cuboid with certain dimensions for the pen insertions. Here the pen insertions are in the shape of cone. So he is asking us to find the wood required to make the stand. So wood required to make the stand is obtained by subtracting the volume of pens holding positions in this, that is 4 cones. So for this, let us initially find the volume of cuboid. For this, let us initially find the volume of cuboid, which is equal to 15 by 10 by 3.5, which is 525 centimeter cube. Now for the conical sections which are inserted here, the dimensions are given by radius is equal to 0.5 centimeters and the depth or h is equal to 1.4 centimeters. Now the volume of the whole sections is equal to 4 times volume of each of cone is pi by 3 r square h, which is equal to 4 by 3 times 22 by 7 times r square is 0.5 into 0.5, that is half into half we can write, into h is 1.4 centimeters. Here 7 goes in 1.4 0.2 times and 2 goes in 0.2 0.1 times, and here also 2 goes in 22 11 times. So we are left out with 4 times 11 times 0.1, that is 44 divided by 44 into 0.1 is 4.4 divided by 3, which is equal to 44 by 30, that can be simplified as 1.47 centimeter cube. Now we get the volume of stand is equal to volume of cuboid minus volume of the space occupied by pen tips, that is 1.47, which is equal to 523.53 centimeter cube. Now coming to the fifth question. A vessel is in the form of inverted cone. Its height is 8 centimeters and the radius of the top, which is open, is 5 centimeters. It is filled with water up to the brim. When the lead shots, each of which is a sphere of radius 0.5 centimeters, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped out in the vessel. Now coming to the solution. Initially here he has given an inverted cone with the dimensions of height as 8 centimeters and the radius as 5 centimeters. So let us initially find the volume of the vessel, which is equal to pi by 3 r square h, that is pi by 3 times r square is 5 into 5 times h is 8, which is equal to, here the 5 times 8 is 40 and 40 times 5 is 200, that is 200 pi by 3 centimeter cube. But he says that he dropped the sphere of radius 0.5 centimeters into the vessel. So now the volume of each sphere V is equal to 4 by 3 pi r cube, which is equal to 4 by 3 times pi, let it be as it is, and r cube is here 0.5 centimeter whole cube, that is 1 by 3 whole cube, which is equal to 4 by 3 times 1 by 2 whole cube is 1 by 8 times pi. Here 4 goes in 8 2 times, so we will be left with pi by 6 centimeter cube. Now he says that he has dropped this lead shots into the vessel. Now the volume occupied by the spheres will be equal to the volume outflown of water. So here the volume of water outflown is equal to, he has given that 1/4 of the water flows out, that is 1/4 times water flown out is, total volume of vessel is 200 pi by 3, that is equal to 50 pi by 3. Let us assume that there are n lead shots, then n times volume of each sphere pi by 6 will be equal to the volume outflown, that is 50 pi by 3, which implies n is equal to 50 by 3 into pi into 6 by pi. Pi goes in pi one time and 3 goes in 6 two times, which is equal to 50 times 2 is 100. Therefore the number of lead shots is equal to 100. That's the solution. Now coming to the sixth question. A solid iron pole consists of cylinder of height 220 cm and the base diameter 24 cm, which is surmounted by another cylinder of 60 cm height and the radius of 8 cm. Find the mass of the pole given that 1 cm cube of iron has approximately 8 grams mass. Now coming to the solution. Here he has given a solid iron pole which is consisting of two cylinders of iron, that is, one is of dimensions diameter 24 and height as 220, the larger one, and the smaller one has a height of 60 centimeters and the radius of 8 centimeters. So now let us note down the dimensions of the larger one. Here the diameter is given as 24 centimeters. So from this we can obtain the radius, which is equal to half of the diameter, that is half times 24, which is equal to 12 centimeters. And here we consider the height of the cylinder, h is equal to 220 centimeters. Now let us find the volume of this cylinder, which will be equal to pi r square h, that is pi into r square is 12 square into 220, which is equal to 12 square is 144 and 144 times 220 is 31680 pi centimeter cube. So let this be as some V1. Now consider the smaller cylinder. For this the radius is given by half of diameter, that is, so here the radius is given directly, that is 8 centimeters, and the height h is given by 60 centimeters. Now we get volume of smaller cylinder is equal to pi into r square h, which is pi times r square is 8 square into height is 60, which is equal to 64 times 60 pi, that is 3840 pi centimeter cube, which is V2. Now we get the whole volume of the solid pole is equal to V1 plus V2, which is equal to 31680 pi plus 3840 pi centimeter cube, which is equal to 35520 pi centimeter cube. If we further simplify by substituting the value of pi as 3.14, we get the value as 532.8 centimeter cube. Now coming to the seventh question. A solid consisting of right circular cone of height 120 centimeters and radius 60 centimeters standing on a hemisphere of radius 60 centimeters is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeters and the height is 180 centimeters. Now coming to the solution. Here he says that there is a solid right cylinder in which a cone surmounted on the hemisphere is placed in it. Initially there is water in the cylinder. Now he is asking, after placing it, what is the volume of water. So the volume of water in the cylinder can be obtained by subtracting the volume of whole cylinder to the volume occupied by the right circular cone placed on the hemisphere. So in order to do that, we need to find the three volumes, that is initially the volume of right circular cone and the hemisphere and the cone. So let us consider first the right circular cylinder. Here for the cylinder, the dimensions are given as radius is equal to 60 centimeters and height is equal to 180 centimeters. Therefore here the volume of cylinder is equal to pi r square h, which is equal to pi times r square is 60 square into h is 180, which is equal to 6,48,000 pi centimeter cube. Now we got the volume of right cylinder. We need to find the volume of cone. So for the cone, the details are given is height h is equal to 120 centimeters and the radius is equal to 60 centimeters. Now the volume of cone, let this be as V2, and initially we found the cylinder, let it be as V1. V2 is equal to pi by 3 r square h, which is equal to pi by 3 times r square is 60 into 60 into 120, which is equal to 1,44,000 pi centimeter cube. Now let us also find for the hemisphere. For the hemisphere we need only the radius, which is given by 60 centimeters. Therefore now the volume of hemisphere V3 is equal to 2 pi by 3 r cube, which is equal to 2 by 3 into pi times r cube, that is 60 cube, which is equal to 1,44,000 centimeter cube. Now we need to find the volume of water left in the cylinder, which is equal to volume of right cylinder minus total volume occupied by hemisphere plus cone, that is V2 plus V3, which is equal to V1 is here 6,48,000 minus V2 plus V3 is 1,44,000 plus 1,44,000, which is equal to 6,48,000 minus 1,44,000 plus 1,44,000 is 2,80,000, which is equal to 2,88,000. Here 1,44,000 plus 1,44,000 is 2,88,000. So we left with 6,48,000 pi minus 2,88,000 pi, that is 3,60,000 pi centimeter cube. This is the solution. If we need further simplification, then this can be transformed as 3,60,000 by, we know that 1 centimeter cube is equal to 10 power minus 6 meter cube. So let us divide it by 10 power 6 into, let us substitute the pi value also, 22 by 7, Then we get the whole simplification value as 1.131 meter cube. That is a simplified solution. Now coming to the 8th question. A spherical glass vessel has a cylindrical neck 8 cm long and 2 cm in diameter. The diameter of the spherical part is 8.5 cm. By measuring the amount of water it holds, a child finds the volume to be 345 cm cube. Check whether she is correct, taking the above as inside measurements and pi is equal to 3.14. Now coming to the solution. Here he has taken a spherical glass vessel with a cylindrical neck. For this, the diameter of spherical glass vessel are given as 8.5 centimeters. Now the radius of sphere is given by 8.5 by 2, which is equal to 4.25 centimeters. So he has also given the dimensions of neck, that is in the form of cylinder, which is equal to half times diameter, that is half times 2 centimeter, which is equal to 1 centimeter, and the height of the cylinder or the height of the neck, h is equal to 8 centimeters. Now the volume of water filled in it can be volume of sphere plus volume of neck, that is in the form of cylinder, which is equal to volume of sphere is 4 by 3 pi r cube plus volume of the neck is in the form of cylinder, that is pi into r square h, that is equal to 4 by 3 times pi into radius of sphere is 4.25 whole cube plus pi times r square is 1 square into h, that is 8, which is equal to, let us take here 4 pi common, then we get 4.25 whole cube by 3 plus 2 pi plus 2, which is equal to, on simplifying this, we get the value as 346.51 centimeter cube. But according to problem, the value got by the child is 345 centimeter cube. Therefore, the child is not correct in the measurement.